Welcome. Today we're diving into the internals of Android's ViewModel. If you've ever wondered how ViewModel manages to keep your UI data alive through configuration changes, you're in the right place. We'll break down what a ViewModel is, why it's essential for modern Android development, and how it operates behind the scenes. By the end of this video, you'll have a clear understanding of the mechanisms that make ViewModel such a powerful tool for developers. Let's start by defining what a ViewModel actually is and why it matters. ViewModel is a core component of Android's architecture components. Its main job is to store and manage UR-related data in a way that's aware of the lifecycle of your activity or fragment. This means your data survives events like screen rotations, which would otherwise destroy and recreate your UI components. The ViewModel acts as a bridge between your UI and your app's data, ensuring that important information isn't lost during configuration changes. This makes it a crucial tool for building robust, user-friendly Android apps. So why is ViewModel so important? In Android development, activities and fragments can be destroyed and recreated frequently, especially during configuration changes like rotating the device. Without ViewModel, you'd have to find ways to manually save and restore your UI data, which can be error-prone and tedious. ViewModel handles this for you, keeping your data alive and consistent. This not only simplifies your code, but also improves the user experience by preventing data loss and unnecessary reloads. When you use a ViewModel in your activity or fragment, you typically declare it with a line like ViewModel, HomeViewModel by ViewModels. This simple line does a lot behind the scenes. It uses Kotlin's delegation feature, allowing the getter and setter logic of the property to be handled by another function, in this case ViewModels. This approach keeps your code clean and leverages powerful features under the hood. Let's break down the ViewModel declaration. The class, like HomeViewModel, holds your business logic and UI data. The by keyword is Kotlin's delegation feature, which allows property access to be handled by another function. Finally, ViewModels is a function that provides an instance of your ViewModel, scoped to your activity or fragment. This combination ensures that your ViewModel is always available and lifecycle-aware. You might wonder, how can we access the ViewModels function directly in MainActivity? Is it an extension function, or is there a special class for it? These are common questions for Android developers, especially during interviews. Understanding the answers helps you grasp how ViewModel integrates so seamlessly with your activities and fragments. ViewModels function is, in fact, an extension function. It's defined as an extension of the component activity or fragment class. That's why you can access it directly in your main activity or fragments without any extra setup. This design makes it easy to use ViewModel in any part of your UI layer, keeping your code consistent and straightforward. For activities, the ViewModels function is defined as an extension of component activity. For fragments, it's an extension of the fragment class. This means that wherever you're working in your UI, you have direct access to ViewModels, making it simple to retrieve or create your ViewModel instances. This seamless integration is one of the reasons ViewModel is so widely adopted. Under the hood, ViewModels relies on the ViewModel provider class. This is where the real magic happens. ViewModel provider is responsible for managing the lifecycle of your ViewModel, ensuring that you always get the right instance for your activity or fragment. It handles the creation and retrieval of ViewModel objects, so you don't have to worry about managing them manually. If you call ViewModels, it uses a ViewModel provider instance to fetch or create your ViewModel. ViewModel provider acts as a factory, managing the lifecycle and scope of your ViewModel. If an instance of the requested ViewModel already exists within the lifecycle scope, it returns that instance. Otherwise, it creates a new one. This ensures that your ViewModel is always available when you need it. Lifecycle scope is crucial for ViewModel management. If your activity or fragment is recreated, such as during a screen rotation, the ViewModel provider checks if a ViewModel instance already exists for that scope. If it does, it returns the same instance, preserving your data. If not, it creates a new one and stores it for future use. This mechanism is what makes ViewModel so reliable for handling UI data. ViewModel Store is a key player in keeping your ViewModel instances alive. It's tied to the lifecycle of your activity or fragment and holds all ViewModel instances for that scope. This means that even if your UI is destroyed and recreated, the ViewModel Store ensures your data survives. It's like a safe storage area for your ViewModels, making sure they're always available when you need them. If a new ViewModel is needed, ViewModel provider uses a factory pattern for creation. By default, Android uses the default ViewModel provider factory. However, you can create custom factories to pass dependencies to your ViewModel. This flexibility allows you to inject services, repositories, or other dependencies, making your ViewModel more powerful and testable. Custom ViewModel factories are useful when your ViewModel needs parameters, such as a repository or a service. By creating your own factory, you can control exactly how your ViewModel is constructed. This is especially important for larger apps that use dependency injection frameworks like Dagger or Hilt. Custom factories give you the flexibility to build ViewModels that fit your app's architecture. Component activity is the base class for most activities in modern Android apps. It provides the lifecycle-aware APIs needed to integrate ViewModel management into your activity's lifecycle. By extending component activity, your main activity or any other activity can seamlessly use ViewModel features, ensuring that your data survives configuration changes and is properly cleared when the activity is destroyed. Lifecycle awareness is at the heart of ViewModel's design. By being aware of the activity or fragment's lifecycle, ViewModel can automatically manage its own creation and destruction. This means you don't have to manually handle saving and restoring data, which reduces bugs and makes your code cleaner. Lifecycle awareness is what allows ViewModel to provide such a smooth user experience. One of the biggest advantages of using ViewModel is its ability to survive configuration changes. When your activity or fragment is recreated, the ViewModel provider checks the ViewModel store for an existing instance. If it finds one, it returns it, preserving your data. This means your users won't lose their progress or data when they rotate their device or switch between apps. When your activity or fragment is destroyed for good, the ViewModel is also cleared. This cleanup is handled automatically, ensuring that resources are released and memory leaks are prevented. You don't have to worry about manually disposing of your ViewModel as the framework takes care of it for you. This makes your app more efficient and reliable. Summarize: the ViewModels function is an extension of component activity or fragment. It delegates the responsibility of creating or retrieving the ViewModel to ViewModel provider. ViewModel provider interacts with the ViewModel store to ensure the ViewModel survives configuration changes. If no existing instance is found, the default ViewModel provider factory creates a new ViewModel instance. This flow ensures your UI data is always available and consistent. Understanding ViewModel internals is a common topic in Android interviews. Interviewers often ask how ViewModel works, how it survives configuration changes, and how it integrates with the activity lifecycle. Being able to explain these concepts clearly can set you apart as a knowledgeable Android developer. It shows that you understand not just how to use ViewModel, but also why it works the way it does. ViewModel is not just about storing UI data, it's also a great place to keep your business logic. By separating your business logic from your UI code, you make your app easier to maintain and test. The ViewModel acts as a mediator between your UI and your data sources, ensuring a clean separation of concerns. The primary role of ViewModel is to manage UI-related data. This includes things like user input, state, and any data that needs to persist across configuration changes. By keeping this data in the ViewModel, you ensure that your UI remains responsive and consistent, no matter what happens to the underlying activity or fragment. ViewModel works well with dependency injection frameworks like Dagger and Hilt. By using custom factories, you can inject dependencies directly into your ViewModel. This makes your code more modular and testable, and it allows you to build complex apps with clean architecture. ViewModel Provider factory interface is used to create ViewModel instances. By implementing this interface, you can control exactly how your ViewModels are constructed. This is especially useful when you need to pass parameters or dependencies into your ViewModel. The default implementation works for most cases, but custom factories give you extra flexibility. By default, Android uses the default ViewModel Provider factory to create ViewModel instances. This factory knows how to construct ViewModels with no-argument constructors. If your ViewModel needs parameters, you'll need to provide your own factory. The default factory is simple and effective for most use cases, making it easy to get started with ViewModel. Suppose your ViewModel needs a repository or a service as a parameter. You can create a custom ViewModel Provider factory that takes these dependencies and passes them to your ViewModel's constructor. This approach is common in apps that use dependency injection, and it helps keep your code clean and testable. The ViewModel store is responsible for holding all ViewModel instances for a given lifecycle scope. It ensures that your ViewModels are available as long as the activity or fragment is alive. When the lifecycle ends, the ViewModel store clears out the ViewModels, freeing up resources and preventing memory leaks. Whenever you request a ViewModel, the ViewModel provider checks the ViewModel store for an existing instance. If it finds one, it returns it. If not, it creates a new one and stores it. This process is automatic and ensures that your ViewModel is always available when you need it without any manual management. ViewModel is tightly integrated with the lifecycle events of your activity or fragment. It's created when you first request it and cleared when the lifecycle ends. This integration ensures that your data is managed efficiently and that resources are released when they're no longer needed. By keeping your UI logic and data management separate, ViewModel helps you build cleaner, more maintainable apps. The UI observes data from the ViewModel, reacting to changes without directly managing the data itself. This separation of concerns is a key principle of modern Android architecture. ViewModel often works hand-in-hand with live data, another architecture component. Live data is an observable data holder that notifies your UI when data changes. By combining ViewModel and live data, you can build reactive UIs that automatically update when your data changes without manual intervention. ViewModel is also a great place to launch Kotlin coroutines. By keeping your background work in the ViewModel, you ensure that long-running tasks survive configuration changes and are properly canceled when the ViewModel is cleared. This makes your app more robust and responsive. Testing your ViewModel is straightforward because it doesn't depend on the Android framework. You can write unit tests for your ViewModel's logic, ensuring that your business rules work as expected. This makes it easier to maintain and refactor your code over time. In large projects, ViewModel helps organize your code by separating UI logic from business logic. Each screen or feature can have its own ViewModel, making your app modular and easier to manage. This approach scales well as your app grows. Save State Handle is a feature that allows your ViewModel to save and restore small amounts of UI state. This is useful for handling process death or restoring state after the app is killed in the background. By using save state handle, you can make your ViewModel even more robust. ViewModel works well with Android's navigation component. By sharing a ViewModel between fragments, you can easily pass data and state as users navigate through your app. This makes navigation smoother and your code more organized. In multi-module apps, ViewModel helps maintain clear boundaries between modules. Each module can define its own ViewModels, keeping dependencies isolated and making the app easier to build and test. This approach supports clean, scalable architectures. With Jetpack Compose, ViewModel continues to play a central role. Compose UIs observe state from the ViewModel, updating automatically when data changes. This reactive approach makes it easy to build modern, dynamic UIs with less boilerplate code. ViewModel fits perfectly into clean architecture patterns. It acts as the bridge between your UI and your domain or data layers. By keeping your ViewModel focused on UI logic, you can build apps that are easier to test, maintain, and extend. Because ViewModel is framework independent, you can use standard testing strategies like unit tests and mocks. This makes it easier to verify your business logic and ensure your app behaves as expected, even as it grows in complexity. State management is a key responsibility of ViewModel. By centralizing your UI state in the ViewModel, you can ensure that your app remains predictable and easy to debug. This approach is especially useful in complex apps with multiple screens and features. ViewModel helps with memory management by ensuring that data is only kept as long as it's needed. When the lifecycle ends, the ViewModel is cleared, freeing up resources. This automatic management reduces the risk of memory leaks and keeps your app running smoothly. To get the most out of ViewModel, follow best practices like keeping UI logic separate from business logic, using live data or stateflow for observable data, and injecting dependencies through factories. These practices help you build robust, maintainable apps. In summary, ViewModel is a powerful tool for managing UI data and business logic in Android apps. It survives configuration changes, integrates with the lifecycle, and supports modern architecture patterns. By understanding its internals, you can build better, more reliable apps. Thanks for joining this deep dive into ViewModel internals. There's always more to learn about Android development and ViewModel. In future videos, we'll explore advanced topics like custom ViewModel factories, integrating with coroutines, and best practices for large-scale apps. Stay tuned for more insights and tips to help you master Android development.